It's space weather. Looking at the sun, 171 angstroms. Got an active region rising. It looks like its activity's gone up a little bit since yesterday. Also, we have the moon moving in between the SDO satellite and the sun. So, to avoid the confusion last time, show you a little trick here. Go to the SDO main page, click on Where is SDO? And it will give you different animations and show you how this can occur. Now, the last time the moon went across twice, and that caused people to believe that it wasn't really the moon. The last time this occurred, the SDO was at this end of its orbit. You can see it does this figure 8 orbit pattern over Mexico and the South Pacific. And in this case, the moon only went past once because the SDO was not at the end of its orbit, at its aphelion or perihelion. Anyway, moving on. Look at some other views here. It looks like the magnetic data has been brushed up. Everything's looking normal. Massive coronal hole facing the Earth. Sure looks like it's magnetically connected, and you can see this active region over here, a little denser magnetic field lines. Here's the 193 angstroms view. You can see that coronal hole. It's a big one, but not the most heavily defined one that we've seen. And 304 angstroms. Check out the plasma filament situation. Mainly the northwest limb. Check out the earthquake situation, because the earthquake risk continues. Now, last 8 hours, we've had 2 500+ kilometer deep Fijian quakes. Something's going on in the Earth's mantle, or the asthenosphere near Fiji. It's been going on for months. Japan got a deep 4.4. Deep earthquakes galore. Alaska got a 3.9 at 120 kilometers. Chile got a 4.7. Man, a lot of quakes hitting California. Look at that. We're not going to go to the U.S. downgrade service site. Now, let's go straight to a random fact. Random fact. Look at our featured channels sometimes. We've got 5 featured channels. And this one here is a video. I want all you sun people, you people who are trying to study the sun, I want you to watch this video. History of the Gaseous Sun with Dr. Robitaille. It's the first video on Sky Scholar. If you go to our featured channels on our channel, click on Sky Scholar, scroll all the way to the bottom. History of the Gaseous Sun. I'm going to play a little clip.
Now, the body of the sun was already considered gaseous in 1865, but back then there was...
Just to give you a little tidbit.
It helps us to see why we view the sun today as a ball of gas, from the surface all the way down to the core. Now, the body of the sun was already considered gaseous in 1865.
Anyway, watch the whole video. It's very interesting. It'll tell you. It'll explain. It'll explain
new concepts in physics.
Please stop playing.
Astronomy.
Oh my gosh,
I am
that
your
tab has
host,
got to go.
Dr.
Watch the whole video. It talks about how the sun was determined to be a gas. And when you listen to the video and you see the history about how we determined that the ball is a gaseous plasma, all the way to the center, you will see what a ridiculous notion that is. Here's your cosmic ray data. We're still at a fairly low level here, which is nice. That's what you want to see. Had a little disparity between DOMB and DOMC in Antarctica. And as far as Ulu, still pretty high actually in Finland, so interesting. Interesting disparity between northern and southern hemisphere. Moving on, we do see some magnetic perturbations, at least forecasted ones. Show you an animation of that. North America. And here's the whole world. Let that play through. Check out Space Weather Enthusiast dashboard before looking at the most intimate solar data. Here's your total electron content. You can see the electron flux has been higher, and the ionosphere's got quite a few free electrons in it by this point. Head to spaceweathernews.com. X-ray flux is back on the floor, so not a significant amount of X-ray flux coming out of that active region, although it is higher than it's been for the past 2 weeks. Phi angle shifting again, suggesting the magnetic connection between the Earth and the coronal hole is broken, but that wouldn't make very much sense. And we've got a KP4 at an unsettled level. Magnetometer is still looking very steep. Not sure what that's going to do next. If it follows what it did yesterday, it should be just about to rise up over 100 nanotesla. Electron flux not quite as high as it's been, giving a little bit of a break to those satellites. Charging hazards are reducing. F2 ionosphere layer is looking pretty normal. There's your auroral forecasts. Here's your solar minimum sunspot progression, your solar minimum 10.7 centimeter radio flux progression, which follows the sunspot number almost precisely. And here you can see that even though we've had a high electron flux, look how low it is historically. It's so low, it hasn't been this low since scratch that. It's actually up to almost 1 times 10 to the 9th there, so it's actually high, but it was recently very, very low. The lowest it was since, what is that, July 16th, I believe. In any case, thanks for watching. Remember, the earthquake risk continues. Please like and subscribe to videos. Don't forget to go back and watch History of the Gaseous Sun with Dr. Robitaille. May the solar wind be at your back and the atherosclerosis absent from your arteries.